Hello everyone, today we're going to be doing the bowling game Kata in Clojure using test-driven development. So we're going to start off by creating a new Clojure project called bowling game and opening that up in IntelliJ. Great, get a terminal open and open up our files here. Okay, we'll start our tests. Okay, we've picked out our bowling ball, our bowling shoes are laced up, and we are good to get started. We're going to start by describing the bowling game. And let's create a context for our first function, which is to score our game. Now, if we just say, I'm so bad at bowling, every time I roll, I just get gutter balls, that means you get 0 points. So if we just pass into our score function all zeros, we should get 0 points back. And that fails because we don't have a score function yet. So let's create that score function. We don't need to worry about any arguments because we just need to return 0. And that passes. Okay, now let's say we got a little bit better and we rolled ones on all of our turns. That means we should get 20 points. So it should equal 20. Score if we just pass in all ones. That doesn't work yet because we're not passing in the rolls into our function. So we're going to take 20 rolls because that's how many turns there are in bowling. And we're going to add those all together. Perfect, that works. So now if we roll all twos, all threes, we know that all that's going to work, right? So what about spares? Well, if we want to start dealing with spares, we have to be able to group things in frames. So we're going to create another helper function called toFrames. And just to start off simple, if we have 0 rolls, we should have 0 frames. So that should equal just an empty vector, no frames, if we pass in an empty vector, no rolls. And that's going to fail because we don't have that function defined yet. So let's go ahead and create that. toFrames. Again, no arguments yet, just return that empty vector. Tests pass. Now in bowling, a frame is 2 rolls grouped together. So we're going to do 2 rolls is 1 frame. Should equal, now let's say we rolled 2 ones. That should be a subvector of those 2 ones. And that doesn't work yet because we need our rolls to be passed into this function. And we need to keep this empty vector here in order to make sure that first test is still going to pass. So we're going to wrap this in an if statement. And we're going to go if rolls is empty, then we're still going to return that empty vector. Otherwise, we're going to do a cons. We're going to create a new vector that is taking that 2 rolls and then passing back into our frames function all the other rolls after that, so they can be sorted into groups of 2 as well. And that works. Great. Now let's go ahead and make sure that if we have more than just 1 frame, we're going to get all those other frames as well. So 3 rolls is 2 frames. So if we pass in 3 ones, 3 rolls of ones, we should get a subvector of 2 ones and a subvector with 1 1. And that works. Cool. Now we can go ahead and deal with spares. So the way spares work is it adds the next roll to the previous frame. So if we roll a spare, let's say 5 and 5, and then our next roll is a 4, that'll be in 1 frame. And that 4 is also from that subsequent frame, so that needs to be in its own frame as well. And that doesn't work yet because we need to check for spares. So let's break this out and wrap this in an if. And if equals 10, the sum of those first 2 rolls. And now if we have a spare, we actually need to take 3 rolls. And there we go. That works well. This line of code here, let's make this its own function for checking for spares. And make sure that that still works. It does. Perfect. Okay. Now, what about scoring? Let's check that scoring spares works properly. Spare adds next roll to score. That should equal 18 if we roll a 5, a 5, and a 4. That doesn't work because we're not using our 2 frames function down here yet. So let's go ahead and use that. And now that things are grouped in frames, we only need 20. There's only 20 frames in a game of bowling. Or sorry, 10. There's only 10 frames in a game of bowling. And since that's a vector of subvectors, we need to flatten that down for reduce to work properly. And we have a stack overflow. So let's lazy seek this to get around that problem. Perfect. Okay, that's working now. Let's go ahead and do a strikes. So a strike adds next 2 rolls to the frame. Similar to spares, but you get that extra roll. So if we roll a 10, which is a strike, and then we roll a 5 and a 4 after that, that should be in that frame, as well as that 5 and 4 being from the subsequent frame. See if that works. And it doesn't, because we're not accounting for that. So we're going to wrap this in an OR, and then say if equals 10, the first roll. So if our first roll equals 10, that means we have a strike. And then we're going to take 3 rolls, just like if we have a spare. And then down here, this needs to be checking for strikes as well. And that's because if we have a strike, we only need to drop 1 roll. And let's see if that works. Perfect, it does. Now we can refactor this here to be a strike function, just like we did for spares. Make sure that still works. Great, let's use this down here as well. Make sure that still works. Perfect. And this chunk of code, we can clean this up by making this its own function that creates that first frame for us. Make sure that still works. Great. And this can also be a function that creates the rest of the roles that we need to pass in. And make sure that still works. Perfect. Okay. Now let's make sure we can score strikes properly. So strike adds next 2 rolls to score. So that should equal 28 if we pass in a 10, a 5, and a 4. That works. Okay, now what about our perfect game? Let's see if our code does everything we need it to. A perfect game is 300 points. So if all of a sudden I just got really good at bowling and I roll all 10s, I should get 300 points. Oh, I gotta make sure I'm putting it in that score function there. Boom. Perfect. We did it. Thank you so much for watching.